All right, welcome everyone. My name's Clinton Hilliard. I'm the program director for Incose, Chesapeake, and along with my co-host Paul Martin here tonight, we'll be administrating this Zoom event. We're going to be raffling off Tina's latest book, Innovating in a Secret World tonight. So in order for me to raffle that off, I need to make sure I match your name with the registration. So just make sure that something close to your actual name is in the your avatar there. So and then, okay, as the meeting goes on here, we're gonna if you have questions or whatever, we're gonna try to hold off to the end, but feel free to put the questions ahead of time into the chat window, and then Tina will be able to get to those at the end of the talk. So tonight we're honored to have as our speaker Dr. Tina Srivastava. As I mentioned, our speaker has recently authored a new book, Innovating in a Secret World. As well as an author, she's an educator, a technology expert and innovator, and an entrepreneur. She's received her PhD from MIT in aerospace engineering, is now an instructor there. She's considered an MIT Systems Design and Management Fellow. Commercially, she's worked as a chief engineer of electronic warfare programs at Raytheon, and very recently co-founded a venture-backed security startup. With respect to Incose, she's served on Incose International's board of directors. She's received Incose's inaugural David Wright Leadership Award and is also the co-chair of the Program Management Systems Engineering Integration Working Group. So with all that, I'd like to now turn it over to our speaker, Dr. Srivastava. Take it from here.
All right, the rest of you don't mind muting as well as taking your video off. That'll be great. Okay, thanks.
Thanks so much for the introduction, Clinton. I'm really happy to be here and glad to participate in our new virtual experience here. So as Clinton said, I do want to see how we can make it interactive. I know that it's difficult making it virtual. So if you don't mind, we'll actually just, if you have any, I'll ask for feedback at various points and questions. So please share on the chat, on the group chat as we go through. And then we'll also have 2 opportunities where we can unmute and have a discussion. All right. So I'm going to talk about innovating in a secret world. I wanted to get a sense for you guys so that I know how I can make sure that some of the examples really relate to what many of you are living through. I'm going to be talking about different working environments, and I know some of you work in government, some of you work in private industry, commercial industry, and some of you work from everything from very small organizations to very huge, giant organizations. So if you don't mind sharing, I'd love to hear a little bit about, if you could just share what industry you work in, anything about your company or organization, that would be really helpful.
Hi, Tina. I'm Dan, and I, like you, I'm also a chief engineer for Northrop Grumman.
Thanks, Dan.
Tina, Clinton Hilliard. I work for CACI as a systems engineer, and we deliver software to large IT projects for government customers.
Paul Martin here. I work for the DoD, and we work in large building size skiffs with lots of fencing around it. And so.
Hi, Tina. Jim DeCamp here. I'm a systems engineer, Department of Defense also, working on kind of embedded system hardware development systems. So check out a challenging effort.
Thanks. Looks like we also have Perry on the chat sharing. So she works in Avid Technology Professionals.
Yeah, Tina, Dave Fadley, also work in defense here locally and do consulting stuff with the government clients.
Yeah, this is Kaz. I have doing system engineering, primarily architecting right now, using MBSE, and it's very interesting to get to use the digital engineering or model-based simulation or model-based system engineering tools.
Great.
George Anderson. Hi, Tina. I'm a graduate aeronautical engineer, as you know, so I'm all excited about all your other activities that you've been doing on YouTube. So I'm looking forward to it tonight. And I've been working in architecture along with Mark and supporting the government.
Awesome. Thanks, George.
You know, I'm Steve Sutton, and I'm retired, but before that I was spent a lot of years in defense and intelligence stuff, and mostly here in Maryland at Fort Meade, and then for a couple of years, 3 years at University of Maryland, leading their system engineering program.
Awesome. Thanks, Steve. Yeah, I was talking to some of the group. I actually spent a short time at the University of Maryland. I spent time at when I was in the NASA Academy at Goddard Space Flight Center, and near Goddard, of course, is UMD, and we were working in the neutral buoyancy tank over there. So great experience with UMD.
So go ahead and unmute yourself if you haven't talked yet. She just wants to know where you work and what you're working on to make sure her talk is relevant in terms of what she's doing.
Hi, Tina. Mark Evans. I was chief of an architecture group, design engineer, senior program manager at a large federal agency in Central Maryland for 35 years.
Great. Thanks, Mark.
And this is David Aldridge. I'm retired after about 30 years working in different places in the intelligence community, and mostly in a skiff. Now I work from home and I have a window.
I was about to say you're getting sunlight now. The rest of us are still not getting it yet.
Yes, that's right.
This is Jim Armstrong. I worked for over 20 years in different programs in the Air Force and DoD, and I've done a lot of training, consulting with all kinds of different industries, and most recently teaching for Stevens Institute of Technologies, and now I'm adjunct faculty there.
Awesome. That's great. Well, I'll just keep going. If anyone wants to chime in, they can. That's super helpful, and I think you'll see why in just a moment. So let me just give you a little bit of expansion there. So I think George was referring to some things that I do. So I'm also very involved in aviation, and not just having a background in aerospace, but very passionate about flying. I actually teach an MIT course on flying, and they just launched a podcast about teaching, and so you can feel free to check it out. We talk about the course that we teach, and in fact, we transitioned a whole bunch of the course material to MIT Open Courseware, which is, I think, the YouTube George was referring to. So you can take a look at your leisure. A lot of folks spending a lot of time at home looking for things to do. So one thing you can do is get your pilot certificate, at least pass the FAA written exam, and that'll get you partway there. So as Clinton mentioned, my background is in aerospace engineering. I'm a pilot. This is, of course, a picture of something you shouldn't see a pilot doing, jumping out of the airplane. I'm also obviously very excited about skydiving. And also, as Clinton mentioned, spent a lot of time at Raytheon. So I think many of you folks have worked either with Raytheon or for Raytheon. So I was a chief engineer there, building large electronic warfare systems, focused on some precision strike and attack teams. It was a wonderful experience, enjoyed it very much. And right now, I'm focused in a completely different world, in the commercial sector, in a startup in Silicon Valley, with some other MIT alums, still addressing some of the similar challenges facing security and authentication, but in a completely different environment. And that's part of what I want to talk to you guys about. And of course, have a great love for Incose, feel very passionate about it. I'm currently one of the co-chairs of the Integrating Program Management Systems Engineering Working Group. So if you're excited about getting involved with that, be happy to talk further about that as well. And then, of course, why we're here today, talking about innovating in the secret world, my book, and would love to share with you those experiences. So diving right in, I want to talk to you about work environments. So given what a lot of you said, I think that these pictures probably sound pretty foreign to most of you. Does anyone or has anyone worked in a work environment like this? I wonder if the folks that also did some teaching might have experienced this. Does this look familiar to anyone in terms of their work environment? Not me, says Kaz. All right. Absolutely.
It looks like Google or Sun.
Yeah, exactly. This is kind of what you think of when you think about Google or Silicon Valley. Definitely not what you think of in the COVID environment, but you definitely see, when you think about innovation and collaboration and fast-moving startups, one of the things you think about are people working together in a collaborative environment. And sometimes now with the COVID environment, a lot of folks are working remotely. And we started off chatting on the call today for folks that joined a little bit early, that some of you, even that usually work in SCIFs, have started working at home remotely, can look out the window for the first time. But it appears that most of us have spent our time in SCIFs. So Perry's also sharing, no, worked in a SCIF, nothing like what you're showing, right? So this might resonate more for those of us who are lucky enough we have a cell phone locker. Otherwise, we just have to leave it in our car. Can you tell me if this resonates a little bit more in terms of what your work environment looks like? Actually, I don't want to put anyone on the spot about sharing this, but certainly some of these symbols like no USB drives allowed, they're definitely not what you would see at Google or in a lot of collaborative environments who might think, that's crazy. I use my thumb drives and iPhones all the time. All right, David's sharing that he's used to these intimidating doors, and this looks familiar to many of you. Okay, great. So what am I talking about today? Well, when you think about national security and how do we address national security, it seems to be the focus that many of us are working on, have spent our careers contributing to. So one way to think about it in the traditional model is that R&D investment leads to technology innovation, technological superiority, and national security. Perry sharing, they'll shoot you if you bring in thumb drives. Yes, absolutely. In fact, my previous startup focused just on that issue itself and securing that issue. I know it very well, and it definitely resonates. So obviously it's no surprise that we're in a very interesting global environment. We have increasing constraints on our ability to fund different projects. So we can no longer rely on having money invested in R&D kind of resulting in technology innovation. We have to be a lot more focused about making sure that the investment in R&D yields the technology innovation that's necessary to drive technological superiority and national security. And one way to think about this are technology innovation strategies. These strategies are very specific ways to go about ensuring that the R&D investment yields technology innovation. So really that's the point here, that if we want to maintain our position in the world, we have to be the best at effectively transitioning our R&D investment into technical innovation. And that's getting harder every day because there's more competition around the world. There's a very complicated geopolitical climate. Our budgets for defense are continuously being examined, being reduced, being spread over multiple things. There's an increasing complexity of technology, right? That's what Incose is focused on. There are these systems or systems of systems. There's some complex systems that require more and more investment. And there are all kinds of legal and regulatory constraints, some specific ones that I'll be discussing today. So how do we become the best at transitioning our R&D investment into the necessary technology innovation? That's what I really want to focus on. Now, many of you live in this complicated world, so this is a chart not meant to be comprehensive, but probably lists many of the places that you guys mentioned that you work. It's a very complicated world, and in this complicated world, it becomes very difficult to, when you look at all the connections and all the interactions here, how do we, transform investments made across this spectrum and tie them to these specific needs that we have? So getting some notices on the chat that yes, it is very complicated, and we can't look at this chart because it might reveal too much about these connections, I guess. These charts also must look very familiar to many of you. This is showing a technology development process, and this is just one of them in the DoD that talks about, the basic acquisition system, talking about all these milestones. So I think many of you might be familiar with, milestone B being obviously a very critical milestone. Can anyone tell me why milestone B is really critical? We got some DAU citations here. Yes, absolutely.
Yeah,
It's
milestone,
effectively
yeah,
preliminary design milestone.
yeah. Milestone B, you go into the actual, I'm going to start designing this thing and building it, right? The contracts are let at that point too.
Yeah, absolutely. It's very critical in terms of, really kicking off a program. And it's, when you think about the way that the DoD works and operates, it's very different from the commercial world and how the commercial world goes about making these decisions. Many people in Silicon Valley, probably 90% of them have probably never heard of milestone B and never heard of TRL levels and all of these different things in here. And so it's kind of interesting to think about when we're working in these environments in this complex world, kind of comparing it to how we do it in a different world. One thing that is aligned in both worlds in some cases has to do with technology development roadmaps. We see roadmaps both in the government and in the commercial world. Here's just a simple example where you got the x-axis showing the time moving forward and various events mapped out here. In the government world, milestone B might be a very critical one. You might have certain RFPs or requests for proposals being critical events on here. In the commercial world, some really critical events are like CES. Does anyone know what CES stands for?
Consumer Electronics Show.
All right. Who's attended the CES in Las Vegas?
About 10 years ago.
All right, that's great. Yeah, CES is quite an experience. I've actually presented there and had my companies present there in the past, and it's crazy because it's global. There are companies from all over the world that come and present their latest and greatest and kind of show off what they have developed. And coming from a skiff world, it's very unusual and strange to have an environment like CES. Yeah, I don't know if they did that virtually. That would certainly be a type of thing you don't want to do in this environment. But even, despite whether it's the government or the commercial world, there's a, mapping to these technologies that are being developed up to certain capabilities that you want to achieve. And so the development of specific technologies that help are shown at the bottom in those blue bars, and they're mapped up to certain capabilities that you're trying to develop. Now, these technology roadmaps and capabilities you're trying to develop, many of you have probably worked on some that are classified. I'll share this tweet with you from the CIA. I think it's a nice joke from them. Might represent some things that you guys feel sometimes, so can neither confirm nor deny that this is our first tweet. So really the question is, when you think about innovation and you think about, a lot of words that come to mind, even when you just Google innovation, are, collaboration, people working together, people sitting on those bean bags in that open space, talking and brainstorming and coming up with all kinds of new ideas, coming up with the next Google, the next startup. And then you think about the world in which all these national security classified operations happen. SCIFs, these scary looking doors, as one of you said. No windows, in a very isolated, siloed world, intentionally siloed because we don't want people to know certain information. So how is it possible that you can have great innovation occur in these very closed, classified environments? Well, we know that it's possible. Of course, the Apollo program being a great example of a program that was classified for national security reasons, of course. We were competing with an adversary. We didn't want that adversary to know. We didn't want them to take away our edge in terms of our knowledge of how we were going to get to the moon, or even what our progress was, how close we were to getting there, how far away we were. All of these things had a lot of bearing on national security. Of course they did. So we know that it's possible. We know that it's possible in classified environments to have incredible innovation and technology breakthroughs, technology breakthroughs that are still benefiting us today, even in terms of using Velcro. But of course, that was a different environment. That was an environment where the greatest minds from across the nation came to the government, volunteered to work at NASA, wanted to be part of the space program. And that type of drive to participate and advance our national security was very unique in our history. And it, might not ever be the case that we could get that type of national energy and drive around something where the best and the brightest mathematicians and engineers would voluntarily come and choose that their top place to work is the government. Unfortunately, the reality is that a lot of smart people choose to work in the commercial industry. They choose to go to Google and Facebook. They choose to join startups. They choose to work all over the place and not necessarily choose working in the government. So how can we still continue to harness that knowledge, that energy, that innovation from all kinds of people, even if we only have a subset of those brilliant folks working in the government on our hardest projects for national security. Well, there was a recent program where we tried to do just that. We tried to get the brain power of people from across the country to contribute to our greatest challenges. Have any of you personally worked on FANG or the ground combat vehicle? So giving a little bit of background, if you're, this is basically the concept of, you know, what we had to do in D-Day in terms of getting to the beach. There is a need for an amphibious vehicle, a vehicle that could travel both on the water and on the land. And it had some of the toughest requirements. The Marines basically came forward and they said, we don't have the ability to get to the beach. We need a vehicle that can help us get there. But this was actually a very difficult program that had, in some cases, conflicting requirements. On the one hand, you needed to build a vehicle that was fast and agile, that wasn't too heavy because it needed to go very quickly and navigate around things and get to where, you know, get the troops to where they needed to go. But on the other hand, you needed to make sure that this system was survivable when there's mines and ammunition and all kinds of munitions being sent towards this. It had to have enough thick, heavy, strong armor to be able to sustain that type of, you know, pounding as it was trying to progress. So, you know, you can see that, of course, those requirements seem a little bit in tension in terms of being lightweight and quick, but also being heavy and strong. And so it became, you know, that was just a quick example. I elaborate more in my book, but there are a number of things about what the Marines needed that were very difficult from a technical perspective. They needed technology innovation in order to crack this nut. It's a very difficult nut to crack. They've been working on it for decades, and they hadn't been able to solve it. They hadn't been able to come up with a vehicle that could address all of those needs and requirements. So they actually created the first open innovation program in the government that sought to address classified requirements. So the specific requirements around this vehicle, such as the survivability, were classified, which makes sense, right? Exactly what type of force it needed to sustain to survive. That's classified because if you shared that information, then an adversary could figure out exactly what they needed to overcome to damage or hurt the vehicle. So it makes sense that you wanted to keep some of this information secret. But it also makes sense that after trying for decades to solve this problem and being unable to do so, that they wanted to take another approach. Well, open innovation is a technology innovation strategy. So one of those things that helps make sure that we yield technology innovation from our R&D investment. And technology innovation strategies involving open innovation have shown tremendous advantages in the commercial world. So we've seen this in many examples, such as the X Prize. Let's take the X Prize as an example. Are you guys familiar with the X Prize and getting to space? It was actually later renamed the Ansari X Prize. So they made it a competition with $1 million prize for what commercial vehicle could get there. So looks like some folks have heard of it. Well, what's great about it is that even though they had a dollar prize of $1 million, they estimated that maybe 10 times that amount of investment was put forward by the teams participating, because many teams participated. So even though the payout was only $1 million, over $10 million, potentially even more, was invested in solving that problem. So that's great. You get a huge multiplicative factor that helps us use fewer R&D dollars to yield the result. It also resulted in a huge multiplication of the number of minds, people working on this and participating. We had ideas from all over the place. We had multiple teams trying to participate. And we know that the winner actually themselves spent more than $1 million. So why were they competing? Well, it turns out that these types of open innovation competitions can generate reputational rewards that are beyond the prize money. So just to claim that they won, Burt Rutan and other folks were willing to put more money in even than the prize money that was there. And that's pretty amazing if you think about it from a national security tight budget environment, that you have a very limited budget. Can you imagine that having the effect of multiplying that budget, having a huge team of folks, having people participating just so that they can say that they helped advance national security? That would be amazing. And that's really the idea of trying to see if we can apply open innovation to national security. So that's what they did here with FANG. So FANG, the Fast Adaptable Next Generation Ground Combat Vehicle, certainly a mouthful, was the idea of getting people to participate in building this ground combat vehicle and overcoming these unsolved challenges that the Marines had. Immediately, they were faced with security issues. How do we deal with the fact that there are classified requirements? If we want people to participate who don't have security clearances, then we can't obviously tell them these classified requirements. Well, the first thing that they did was divide up the competition into 3 phases. So those are the 3 that you see on the slide here. The first being the drivetrain. They figured the drivetrain is very important, but it also is least likely to have classified requirements. So we could have maybe a global participant pool of people, making teams, submitting ideas, and participating. Here it shows, this was an in-progress slide, so it shows that they were looking at $500,000 to $1 million prize. They set it at $1 million, just like the X Prize. The second was looking at this, the chassis. Now this has the survivability that we just talked about. So as you can see, highlighted there under the participant pool, it says, may accept secret level submissions, ? This is something that they sought to do. And then the total platform challenge, so building the full ground combat vehicle, they similarly were hoping they could accept classified requirements. Now this was a great effort. They really did a lot to try to address these issues. I explained some of the details in the book in terms of what the program managers were trying to do, how innovative they were in their approach to innovate, and some of the challenges they ran into right away with ITAR and the State Department. They immediately had to limit that participant pool from global to US only to overcome some of those challenges. And at the end of the day, they were successful in completing the first phase of the challenge. They awarded a design team that met the requirements, the prize money. However, they weren't able to proceed with phase 2 or phase 3. Both were canceled because they weren't able to address this specific issue of these classified requirements. So that's what I want to talk about. I don't want to take it for granted that why are we even thinking about open innovation? I work in a SCIF. I have no windows. That's how I've been working for decades. Why should I even think about the concept of open innovation? Well, I actually think we're in a unique environment today. Many of you that are working remote, yeah, sure, it could be that you're working on something unclassified. A number of the agencies I've spoken with, I actually just been working with NGA, the National Geospatial Intelligence Agency. So much of their work was classified, but actually because of COVID, because of the coronavirus, because of the need to be resilient, they tackled this question of secrecy in a very unique way. And many of the things that they did in terms of mapping and analysis, they figured out how to do on the low side. And so while obviously there remain programs and projects that have to be on the high side, an unprecedented amount of work that the NGA did classified is now being done unclassified. Now that's a huge thing. And I would argue that national security and secrecy are often conflated. So what I mean is we just assume that anything associated with national security should be classified. In fact, even the definition of secret and top secret refer to this concept, saying that the definition is revealing this information would result in grave danger. So it's all about the concept of secrecy, because the danger is that it would hurt national security if this information were revealed.
A good example of that for NGA is Katrina, when the hurricane hit. For the first time ever, NGA got permission to release satellite imagery to help out with the navigation and damage assessment after the Class 5 hurricane had devastated that region. And once they thought about it, they realized the only thing they really wanted to protect was what the resolution was. So they changed the resolution that they released the photos at, and it was problem solved. And they figured out that they didn't have to conflate the secrecy with national security. And it was very beneficial. You know, the Coast Guard was really able to help rescue people and avoid a lot of water hazards using that imagery.
Yeah, that's an amazing example. Yeah, and with an actual tangible result there, you know, saving lives, which obviously helps national security, was enabled by actually declassifying something. And that's sometimes hard to get our heads around. And I know what you mean. Working electronic warfare, almost everything we did was classified. It was just assumed it's behind the wall. That's just how it is. You don't really question it. But there is an idea here that what if it were the case that to solve a problem that's very tough to solve, that if you could actually declassify some part of it in order to enable open innovation, other people to collaborate and help solve the problem, that solving that problem actually advanced national security more than opening it up hurt national security. And so that's the trade-off. And this example that you gave here was fantastic about Katrina. You know, they found a way to just, you know, it was just resolution that needed to be classified. And if you can be more specific about what needs to be classified and what doesn't, you can have an incredible impact. And that's really what this quote here is saying, that pooling the brains of 300 million Americans could turn out to be a masterstroke if DARPA can traverse issues such as classified requirements. I also just want to talk about, you know, what does success look like? So there have been many efforts over the years to declassify information where possible for various reasons. Well, this is an example of a document that's definitely ticked on the success mark in terms of being declassified. But as you can see in this, you know, one-page document, only about 2 sentences are actually readable. Here's an example of a 4-page document that is marked, you know, this is declassified, but there's only a couple sentences on one page that you can actually read anything on the document. So, you know, we have to be a little bit more specific, and I dive into it in the book, thinking about secrecy challenge. You know, what does it take? What does it take to know that you're successful? But also, you know, who has to be empowered to make that decision? You know, we're not. I don't think any of us are original classification authorities, and so we don't have the right in some cases to make these decisions. And that's something I explore further in the book. But I want to shift a little bit towards incentivizing participation and how we get innovators to actually participate in the process of innovating for national security. So I'm going to go into a bit of a history story, if you'll bear with me. So let me take you back in time. Let's go to the spring of 1918. The Germans launched a major offensive on the Western Front. So I think we're all familiar with this, with this time. This is one of the bloodiest wars we've ever seen. And this is a very difficult time in the war because we're not sure at this point if we're going to be successful. This offensive really shook the confidence of the Allies. Now, sure, we later were able to rally and win the war, but at this particular moment in time, we didn't know which way it was going to go. Okay, so what you see in this picture here are some battleships, and they're powered by steam turbine engines. Okay. Well, it turns out that there is a company that had a patent on steam turbine engines. However, it wasn't the company that owned the patent that was manufacturing these steam turbine engines for the government. It was a different government contractor. And in fact, the government contractor was infringing on that steam turbine engine patent. So they filed a lawsuit and said, "You're infringing on my patent," and asked for an injunction. Now, an injunction is a very serious thing. For a patent owner, it's a very strong remedy that we can actually stop you from making the steam turbine engines because you're infringing on the patent. Now, the patent system had never really faced a wartime issue like this. And in fact, it would have been correct and valid to issue an injunction. Now, can you imagine that, being in the middle of a war, relying on these steam turbine engines as your primary, power for these battleships, and being told you have to stop making the battleships in the middle of war? Now, obviously, the patent owner seems like a real jerk. Everyone's like, who is this guy? Why are they doing this? This is unpatriotic. What's going on here? So I want you to hold that thought, because I'm going to come back and flip it around in a little bit. But right now, it really seems like this patent owner is really being terrible. Well, what happens is, after the court reviews the matter and they say, yes, in fact, this government contractor is infringing on the patent and an injunction is possible, Congress says this is a problem. And in unusually swift action for Congress, they actually made a law. Who has heard of a law called authorization and consent? I'll give you a chance to mention on the chat if you've heard of authorization and consent or ever worked with it. But you might be surprised to know and learn that authorization and consent is probably a clause in every single government contract that you have worked on. Well, this law that they made in a rapid format actually took away this remedy from patent owners, this idea of an injunction, and it just said injunctions are not allowed. The sole remedy against the government or government contractors is actually a lawsuit against the government. And this is the beginning of statutory immunity. So this means that you can actually violate other people's patents and be immune to having any repercussion for doing that patent infringement. So it's actually as bad as it sounds. So a government contractor can intentionally infringe patents, and the patent owner has to sue the government to try to get compensation. Now, this is a big limitation. I won't get into the full patent law. I love this topic. I explored a lot in the book, but there are a lot of things that a patent owner should have gotten in a normal suit, especially with intentional infringement. You get damages, you get all kinds of things, you get attorney's fees, but in the case of the government, they took that away. And it makes sense, right? If you think of the context, this was 100 years ago, we're in a war, we need access to that steam turbine patent, and we're not going to stop making the steam turbine engines in the middle of a war. That's preposterous. But that law actually has a lot of unintentional repercussions. I mean, that's what systems engineering is all about, these system level effects that you didn't think about. Well, it turns out that law, which made a whole bunch of sense at the time 100 years ago, has never been amended and is actually discouraging innovators from innovating for national security. Before I keep going, has anyone heard of authorization and consent? I got a no. Okay. Well, I really encourage you, so many of you that work on government contracts actually guarantee you that there is a FAR clause in there on authorization and consent. Well, here's the oh, let's see. Mark Evans says, yes, you are familiar. Okay, Mark, that's fantastic. Do you have any experience working with authorization, consent, or the implications of it?
He's probably talking and doesn't have his mic unmuted, so you have to encourage him to unmute.
Sure. Yeah, I
Well,
think
I
we
do
muted
have,
him.
I typed in the text, and I was in a design job one time where we had technology from AT&T out of Bell Labs. It was state of the art. It was their signal processing chip. They had an entire signal processor on a chip, and they allowed me to go up to Bell Labs, learn how to use it. And the people there at Bell Labs teaching a course, Richie and Kernigan, and a lot of their sharpest people. And I came back with myself and two other engineers. We put that chip into a system, and it worked out really, really well. And unfortunately, some of our managers shared it with some of our allies, and long story short, the technology, which was patented, it wasn't even on the market yet, found its way into third-party European company, and they started marketing it as a speech rate changer on a dictaphone because it had a lot of advanced speech technology behind it. And the only thing that saved me from jail was they used a T&I chip instead of the AT&T chip when they stripped out the design. So the algorithm itself to change speech, playback speech at pitch synchronous rates at a lower speed, that was, fortunately for us, that had been designed by a senior scientist in our agency, and it was in public domain, so there was no lawsuit there. But I learned the authorization and consent in the whole detail because first AT&T wanted to put an injunction up, and they could not. And then they tried to take the system out of operation, and we had it in production in large production numbers, which for us were 4,000, which was unheard of. Usually we built onesie twosies, but this was a speech rate changer you could slap on the back of a tape recorder. And so then they tried to sue the agency, which they couldn't do, but they could name an individual in the lawsuit, which was me. So I became good friends with our patent office for about 1.5 years while this all got resolved. And that particular law was what prevented AT&T from stopping anything. And then the way it all worked out, they finally agreed that they hadn't lost their technology because of the T&I chip that was used over in Europe. And the Europeans got away with murder. They stole the design, stole the system, stole everything but the guts of the system, which was the AT&T chip. So yeah, it was kind of an eye-opening education. When you have a major US corporation naming you individually in about a $2.5 million lawsuit, it's pretty bad.
Yeah, it sounds like you really understood, got into the details of that. I mean, I'm sorry that happened, but I'm glad that it worked out in the end.
Yeah, it all ended very amicably, but it was interesting to me how the agency did not take any of the lawsuit. They stepped aside and let the individual me get named. So I did get to use the government's patent attorney, but that was about the only benefit to that.
Yeah, absolutely. what this, just your example was so perfect there to talk about it, but yeah, this authorization and consent is really talking about that right to use the patent. And in the case that we just talked about with the steam turbine engine, the patent owner is a person that seems like the person in the wrong, that, how are you stopping this in the middle of war? But actually, one of this unintended effects probably, and may have played a role in your story there, Mark, but unfortunately it actually has impacted the ability of, really well-meaning folks for innovating in national security. So I'll give you the example of Tenebrex, and then I think we'll have to wrap up because we're getting close on time, but I really appreciate the participation here. Well, Tenebrex was a case where there was a company called Tenebrex that invented some really awesome anti-reflective coating for rifle scopes. And this coating was amazing. It really worked very well. And pretty much every rifle scope now has that anti-reflective coating. Well, Tenebrex invested their own money to develop this coating and filed patents on it, and wanted to, give that to the Army. They wrote a proposal to the Army for that to provide that anti-reflective coating. And the Army agreed that this was fantastic. They needed it. It was necessary. And I actually worked in the plant where these rifle scopes were being manufactured in McKinney, Texas. And unfortunately, what happened though was that the Army didn't award Tenebrex the contract. They actually awarded a competitive contractor the contract and required that they used Tenebrex's anti-reflective coating patent. That's pretty eye-opening for a lot of folks, because it's basically asking a company to infringe and not providing any compensation for the patent owner. And in fact, ouch, says Kaz. I agree, it's terrible. So the CEO of Tenebrex was just saying that the problem with this is obviously it disincentivizes them from continuing to innovate, because if they, if they invent something great that the government wants, they're not getting compensated in any way. Their competitor is getting awarded. And, Mark, you mentioned working closely with these legal folks. Well, actually, the corporate counsel for the competitor that won the contract said, we don't have any need to even look at their patent or the validity of their patent. We can just infringe openly. They can be very open about infringing, because authorization consent grants them immunity to do so. So in this case, there's kind of a balance that we have to grant, because I understand why the Army did this. The Army wanted to have these rifle scopes immediately manufactured in bulk with all kinds of complex requirements. Tenebrex was a small company, small innovative company that came up with something great, but they weren't actually the company that was best suited to deliver the innovation. And that's actually, if you rewind to the steam turbine engine case, the same thing, that the patent owner wasn't the best suited to deliver those steam turbine engines for all the battleships. And that's why the government was working with that other company. And so we have to find a way to balance, because we want to continue to incentivize the innovator. The innovator is the one that's putting forth the R&D investment to get that technology innovation that we need, the steam turbine engine, the anti-reflective coating. We need these innovations. We need them to continue to happen. But we also need to incentivize that government contractor, because if that contractor that's making those steam turbine engines thinks they're going to get sued, they're not going to keep making them. Same with the rifle scope manufacturer. And so we have to find a way to incentivize both the company that's innovating and the company best suited to put forward that innovation. And this is, again, back where I will talk about innovation strategies, because we have to look at this problem not as a zero-sum game where if there's only $1, it goes to either this guy or this guy, and any dollar one gets, the other one doesn't get. But we have to look at what happened in open innovation, where we saw in that example of the X Prize, people putting forth more money than the prize money because of a reputational benefit. And that's what I describe and go into a lot in the book, that there's actually a way you can incentivize both of these folks without any downside. It's possible that the government could have announced that, hey, these are anti-reflective coating by Tenebrex. They could have promoted Tenebrex and shared that this is an innovative company. That could have helped Tenebrex get more government contracts and expand what they were doing without necessarily having to put forth all of the money to do that. I know you guys have questions, so I'll just wrap up and get to the Q&A here. But what we talked about is that many of us work in SCIFs, and we work in these closed environments that are so complex and so regulated and so dark that it doesn't look like the places where people do the innovation. Now, we know in the case of Apollo, it's possible to do incredible innovation in these environments. And we have to find ways, such as open innovation, looking at technology innovation strategies. What are some strategies that we can borrow from the commercial world that help us advance with limited R&D dollars to technology innovation? And we talked a bit about the secrecy challenge for doing this, and some of the challenges of even declaring success when something is declassified, but also the participation challenge. There are a lot of challenges here, and I address in my book some of the people that are in a position to actually make a change with regard to authorization, consent, and other IP and sharing mechanisms. So this is my book where I talk about this more in detail, and I appreciate Kaz holding that up and showing the copy there. There are also 2 articles in the National Defense magazine, which is NDIA's magazine, about the book. One in the September issue and one in this more recent issue, talking about the NDA Centennial Edition, where they discuss the future of warfare. And there's also a MIT Sloan article that talks about why the U.S. government is struggling with open innovation and discusses the book in more detail. So there's some more resources for you to look to, and I'm happy to open it up and discuss more. I see the questions already coming in.
Thank you, Tina. Yeah, so there's a couple questions already submitted. I think Mark has one there. Others, feel free to submit. And then when we're done with the questions, I'll get to the raffle.
Great. Well, looking at to Mark, and Taras is also mentioning how Apple cloaks their R&D and secrecy, and that they're actually industrial settings where extreme secrecy is there, motivated by, let's see, the desire to be first to market. Yeah, absolutely. So there can be motivations other than national security for secrecy. That's true. Let me give you a specific example in terms of pharmaceuticals. We know that the pharmaceutical industry is one of the ones that has the most secrecy associated with that. That drug development, you're talking about millions and millions of R&D dollars invested into developing those drugs, and they're very, very secretive about what they develop. Well, even in that industry, they have found ways to enable open innovation. So Roche Pharmaceuticals, one of the big giants there, had a specific problem that they were trying to solve that they hadn't been able to solve in a very long time. Well, they actually used a platform called Incentive, where they made an open innovation request for people to submit ideas. Well, it turns out in the 60-day time frame that they opened that challenge, they got more ideas than they'd ever had, of course. But interestingly, they got every idea that they had ever come up with previously. All of the ideas that they had internally developed, they got in that forum, in addition to new ideas, and of course, an idea that actually cracked the nut and solved the problem. And of course, as it shouldn't be any surprise, the winning idea came from a person from a different discipline. So that's all we know about that in systems engineering, cross-disciplinary interaction. And in fact, that's where innovation comes from many times, is from a different discipline. So they found out that in a very short amount of time. So they were able to accelerate innovation because they'd been working on this problem for over a decade, and within 60 days they were able to solve it. So they accelerated it. But they were also able to actually, enhance innovation. They got all the ideas that they had before, but even some new ones. So even commercial industries that are cloaked in privacy have found ways to be specific about things that they haven't been able to solve, and open that up so that they could actually use the R&D strategically to make some technology innovation happen. And I'm seeing a lot of questions on the chat. You're also feel free to unmute and ask a question also. I'll take the next one here. So Dave is asking about how government agencies are trying to emphasize in-house innovation, and how do you create a culture of innovation inside a large government organization? Yeah, absolutely. And actually, I would say, drawing on what I said earlier about this COVID environment causing a lot more things to happen in an open environment, I actually think the culture is already changing. This is a great time to have this presentation because we're living in a world where a lot of those hard decisions that might have been delayed for decades about whether this could be done, in the open, weren't, because it was easy to default to doing things in a closed environment. But now a lot of things are coming out into the open. People are having to work remote. They want to enable their workforce. And a lot more things are happening in the open than ever were happening before. So I think the culture is already changing. And the real question is, can we take advantage of that culture change, that now that more things are happening in the open, can we use that culture change to now collaborate with others? Once something's unclassified, it's a real opportunity to collaborate with people that you haven't collaborated with before.
Okay, I think that's good. Are there any more questions? Oh, there is one more. See if you talk to Jim's question as well there.
Sure, I see Jim and Paul and a few other questions here. So, okay, so before Jim is this other question about having innovation in a large skiff. Yeah, absolutely. So one of the things that I discuss is that, there are different degrees of openness. I mean, the FANG program showed that it didn't have to be global. Even within the US, they were able to do that. Well, actually, you can limit it even further. There are ways to do innovation just among people with clearances, or even clearances of a certain level. Anything we can do to open up more than we are right now. There are also just different ways to implement these strategies. So instead of just having one particular team working on a problem, it might be possible to shape the problem, to shape some of the work around it in a way that you can collaborate with others in the field. And I'll also throw out there, I know there are a lot of points throwing out here, but it's not always the ideation phase that you want to open up. You could also open up the idea selection phase. And I talk about the different parts of the innovation process. So what I mean, for example, is, you could have different teams ideating and coming up with different ideas. But then you could also even open up to that large skiff, to your question, to that large group of people to vote, on the best ideas, weighing the requirements in a different way, looking at things from a different perspective, and not singling it to one or two decision makers can actually open up the innovation process in a different way that might be more suited to a skiff environment as well. Okay.
Tina, I'd like to ask you, do you have any experience with personnel systems and strategies for rewarding the different groups? And one of the issues has always been individual rewards versus group rewards, and whether or not you establish or create a hero culture by, heavily rewarding the individuals that shine individually as opposed to teams of people that don't get recognized.
Yeah, Mark, I can hear in the question that this is something that you've been thinking about for a long time. I do talk about that, and I think there are a lot of ways that we can change how we do that reward system, because one thing I address in the book specifically is that within, the government doesn't get to always directly incentivize the innovator. The innovator might be an employee in a large organization. And so the way that the organization incentivizes the employee to put forth the idea is a very critical part of the government ultimately getting the idea. And I discussed kind of what the standard run-of-the-mill rewards are, like an innovation award or $1,000 or a dinner. Sometimes that's not enough to really motivate people. And oftentimes I found that there's really a big disconnect between the value of the innovation and the reward. And many times the reward is a very static thing, regardless of whether that innovation affects, it's a very big problem we're trying to solve for decades, or whether it affects many people. Nothing about kind of the scope or the benefit of that innovation is reflected in that award. So that's one way to do it. And then regarding this hero culture, I think that one of the things I do discuss in the book is about certain kind of favorite people being picked many times to get these innovation awards, and a lot of it has to do with the fact that it's sometimes difficult to navigate that patent process within a company, and a few individuals have figured it out. They know how to submit a patent that'll get selected and that they'll get an award, and so they kind of keep doing it, whereas other folks don't really know how to navigate the process. They don't have supervisors that are supporting them in terms of giving them time. Many times it's, if you've heard the term, on your own time. So you have to work on submitting these innovations on your own time, as opposed to having leadership that encourages you to put forth those innovations. And I think you might see that in terms of encouraging teams, that in fact the culture of the organization, the team, the management doesn't see the benefit always of putting forth those ideas, and especially in informal innovation processes. So I do discuss some of those. I think there are a lot of ideas there, and just like we've discussed about expanding the pie, I really do think that there are a lot of non-monetary incentives that are even more effective for rewarding teams and rewarding individuals in innovating. And so just having a reputational advantage, promoting the fact that a team made a contribution and really tying their contribution to the impact it had can make a big difference. And happy to discuss that further.
Great.
Got a whole bunch of questions on the chat
we have
here.
two ones. One dealing with trade secrets. Would that be a better way to go than patenting? And the other thing is the need to know restrictions is a very preventative situation. So if you have any comments on them, that'd be great.
Yeah, thanks. So with regard to trade secrets, I think that this one's really interesting. I'll be delicate in how I say this. I have a section on the book that talks about this. I will say that, okay, so the idea of authorization and consent, we went into it for a long time, is the idea that the government should get access to patented technology, right? And they can sort of co-opt that technology. They can have their government contractor that they're most comfortable with, develop that technology, even if they're not the one who innovated. So having the technology patented is one way to put forth that innovation to the government, because the government can now take that patent and have others produce that technology, like we saw in the case of the anti-reflective coating and in the case of the steam turbine engines. So what happens when a company chooses to make it a trade secret instead of patenting it? Well, it actually means that the government didn't get access to it now, because that whole method of authorization, consent, and sort of co-opting that patent goes away if the government doesn't know about it, if it's secret, if it's a trade secret. And so that's kind of a trade-off that happens. There's also some, I would say, funny accounting that happens a little bit when you think about some dimensions of government contracting, and I get into the book. I'm happy to talk about that more offline, where people talk about who was funding the innovators at the time the innovation happened, and whether those things could be made trade secret or not. And that's a really detailed area that I think is relevant to this concept about trade secret versus patent that's very pertinent to that topic. And then I think you mentioned this need to know restriction. Yeah, I think that it's a big problem, and I think that it negatively impacts national security, because and I go through some examples I talk about DARPA program managers when they're creating a program. And there are a lot of really great things about how DARPA innovates. One of them being that they have to do things very quickly and rapidly, and DARPA program managers are only there for 4 years. They have very short period of time. But one of the problems with that, with being there for such a short period of time and having to kick off a program very quickly, is that, and many other programs are classified. So when you're starting a new classified program, the DARPA program manager has to figure out who are they going to tell, who has the need to know that they're going to even share of the existence of this new DARPA program, so that folks can put forward ideas. And that need to know really, it puts up barriers to collaboration, but it also just narrows who you're working with. It's really, by the nature of it, limited to who the DARPA program manager happens to work with. That's who they can justify has a need to know. They have that appropriate background. Whereas if you could, publicize more openly, you can get different people to put forward ideas, and you're really limiting your pool there. So I do go through some examples where I think that the need to know in particular is hurting national security in certain areas. Obviously, in certain areas it's required, and I talk about that as well. But I think that there are certain areas where certain aspects of a program shouldn't have that restriction. Otherwise, it can actually impede the innovation required for national security.
Excellent. Thank you so much, Tina. That was a wonderful talk and very timely for us.
Can I get one more quick question in?
Yes.
Doctor, are you familiar with what CIA did with In-Q-Tel to try to expand their innovation and make it a little more public to people?
Yes, pretty intimately familiar with In-Q-Tel. Have you worked with them?
Yes.
Yeah, I have a section in the book where I talk about these VC arms. There were actually 2 other agencies in the government that actually tried to develop them, but In-Q-Tel is certainly the biggest and moving forward the best. What's your experience with them?
I was on some very deep black programs that were multi-agency. And rather stunning to me when I first started there was how much of the technology that was being done for some of these programs were actually shared publicly and being developed across a pretty broad contractor base. And so it seemed like they had come up with a pretty effective way to share information and technology that could help a broader number of people and just not keep it locked up and wrapped up. We actually found solutions by dealing with In-Q-Tel that had been developed by other programs that were really really valuable. And to this day, I question whether we would have stumbled on it had there not been something like In-Q-Tel.
Absolutely. And I think that the idea of In-Q-Tel is great because, they're located in Silicon Valley. Of course, if you go to their offices, there won't be any sign or anything that mentions them. But once you get in there, I'm convinced now that I did in fact talk to In-Q-Tel. But at the time, some of the founders of the startup were like, "Did we just talk to some random people in a room, or was this really In-Q-Tel?" But yeah, they've embedded themselves in Silicon Valley, in Cambridge near MIT, and in places where these startups are people in open world. So obviously they're getting access to innovations that may not be present in certain places near where you guys live, and that's very helpful. I will raise some concerns that I have about it though, which is that and this is a problem, so being in the startup world and interfacing with investors a lot, some folks actually take a lot of issue with In-Q-Tel and kind of how it works, in the sense that the way that the revenue model works and not knowing too much about who the customers are oftentimes cause venture capitalists sort of discount the revenue that comes through that form from In-Q-Tel. And the problem with doing that is that, that's just sort of the nature of how it is. But the problem with doing that is it sort of disincentivizes founders from focusing on getting that relationship with In-Q-Tel. So I think they've done something really amazing, and I think it has a lot of benefits. And I think there's certain things that they could improve on to make sure that they continue to get that stream of innovators participating and don't lose some of that over time.
Okay, thank you, Tina. We're running a little long here, so I think we'll wrap up the question session here.